Hello friends, welcome to EC Academy. In this lecture, let us understand the maximum power transfer theorem. It states that the maximum power is delivered from the source to the load when the load resistance RL is equal to the Thevenin's resistance RTH of the network as seen from the load terminals. So, the condition for maximum power transfer is RL is equal to RTH. So, in a given network, if the load is equal to the Thevenin's resistance, then the source will deliver the maximum power. So, the maximum power can be given by the formula 1 by 4 times VTH square divided by RTH. So, this is the formula for the maximum power transfer. So, from this formula, you can understand that we can find the maximum power delivered by the source by finding the Thevenin's equivalent voltage and Thevenin's equivalent resistance of the given complex network. So, whatever electrical network they give, first find VTH and RTH, then you can find the value of maximum power delivered by the source. Let us consider an example. Here, we need to find the load resistance RL where the source deliver the maximum power. So here RL will be equal to RTH. First, let us find the Thevenin's equivalent resistance. To find RTH, we need to short circuit the voltage source and we need to remove the load resistance. Then we need to find the equivalent resistance between the point A and B. This is the redrawn circuit where we need to find the Thevenin's resistance between the points A and B. Now, we can simplify the resistors that are connected between the points A and B. So, 6 ohm parallel with 12 ohm will be in series with 10 ohm. So, we can write 6 ohm parallel with 12 ohm plus 10 ohm. So, this is nothing but RTH. So, if we simplify this, we will get RTH is equal to 14 ohm, which is nothing but your RL. Now let us find VTH. To find VTH, we need to remove the load resistor and we need to find the voltage between the points A and B. Let us redraw the circuit. Now let us find the equivalent Thevenin's voltage between the points A and B. Now A and B are open. There will be no current flowing through 10 ohm resistor. That's why we can neglect this resistor. And for the remaining part of the circuit, we can find VTH. Now we can find VTH using voltage division rule that states that resistor where you are finding the voltage divided by sum of the resistances multiplied by a source voltage. So VTH will be equal to 12 ohm divided by 6 ohm plus 12 ohm multiplied by 9 volt. So VTH will be equal to 6 volts. Now we have found the values of RTH and VTH. We need to calculate the maximum power using this formula. So we can write P maximum will be equal to 1 by 4 multiplied with VTH is 6 volts divided by RTH is 14 ohm. So if we simplify this, we will get P maximum is equal to 0.64 watts. So this is the maximum power that is delivered by the source when RTH is equal to RL. This is about maximum power transfer theorem. You can use this concept to solve any problem. Hope you have understood the topic. Thank you.